Hello everyone, I hope you are all doing well. Welcome to our today's class. So we're just going to do a recap of what we did yesterday and then continue with it. Yeah, because we're going to be working with joins as many times as possible. Yeah, so that we can try and see whether we're going to manage and finalize our class today, since tomorrow we won't be having a session. So yesterday what we majorly focused on is joins. Apart from us learning how to use more aggregate functions, we did more of joins, and with joins we were able to learn how to join more than two tables, and today we're going to learn also how to join more than also two tables, let's say 3 tables also. Yeah, and also create new columns using another function that is used in SQL. So I don't know whether we had a challenge in our yesterday's work or someone is having a question. Hello, can you hear me? Okay. Alright, so I'll do the second query, whereby we're supposed to extract employee number, and we have first name, last name, and the average salary, of which both of these are coming from just 2 tables. So we're going to be extracting both of them. Yeah, so I'll just write my function just below where we're having our query area. Yeah, so when we talk about extracts, that means we are selecting something. Yeah, we are selecting a column from a table. So we have select function. Okay, let me just do something. Let's just increase our font, but we are all able to see it. So I have the select statement. So I'm selecting one employee number, and of course this employee number is going to be coming from employee schema, employee table. Employee schema, make sure it's selected. Then we have the schema is employees. So I'll use E to abbreviate employees. So I'll have we have select E dot emp number we have comma E dot first name then that's first name. We have E dot last name space. We have last underscore name, and then we'll have the last column will be selecting the average salary from the salaries table. So what I'm going to do, I'm going to start of course with average, that's AVG, then in brackets I'll have not only salary but S dot salary in within the brackets, so that we're able to select where this which table are we getting the salary from. So I'll have S dot salary, and then I enclose that. That means I'm selecting employee number. We have first name, last name, average salary, yeah, and make sure you abbreviate the salary column. From that, we're going to specify where we are selecting these columns and then the joins. So from employee table, bearing in mind that the employees, because it have come after the from, it is the left table, abbreviated as E. Then we are going to be using join, yeah, and since we have already specified our column with the employees table as our left table, that means the salary table will be our right table. And for this purpose, because we're looking more into the average salary, so that means we need all the column from the average salary. In other words, all the columns from the right table, yeah. So I'll use right join, right join. Then we have salaries, abbreviated as S, and then we have the matching columns on. Where are we getting our data set from? Not getting, what are the matching columns for these two tables? If you check on employees table, we have employee number, and on salaries table we have employee number. So those are the matching columns, yeah. So we'll have E dot emp number is equals to E dot sorry, not E, S dot emp number. So E for employees and S for salary. So we have the employee number from employees table and employee number from the salaries table. So let me run that. You can't see the output, that means I'm having an error somewhere. Let me just expand this. It's not visible. So okay. So since we are using an aggregated function, that's the average. We earlier said when working with aggregate function, we are required to use the group by function. Yeah, remember what we said when we were working with aggregate functions yesterday? We said wherever we use the aggregate, we are required to use the group by function, so that the average will be grouped according to the output displayed. So back to my query, and in this case, group by function or the having clause or the order by function will always come at the end of the query, whereby you have selected, you have joined. Hello, can you hear me? Okay, right now, or I was gone for a while now? Oh, okay, let me share my screen. I just realized the connection is poor once the screen was gone, but I'm sharing right away. Sorry for that. I hope my screen is visible. Sorry for that. So as I was saying, the error was saying, you can see the message error here. I didn't want to move it here at the middle here, where the error message is saying that in aggregate query, in aggregated query without a group by function. So we need a group by function. So we're going to group by here after our matching columns. After you have indicated which columns are matching, then you go ahead and use the aggregate function, the group by function. Yeah, so I'm going to type group by here. Group by, you can group by our employee number. Yeah, and see the output that you're going to be getting. Of course, you can have as more functions, especially when you're working with a specific condition. So let me just use group by and then see the output. So you're grouping by, okay, welcome. So we are grouping by e dot employee number. Yeah, so I've grouped by employee number. Otherwise we can also add a condition. Let's see the output. I don't know why it's taking so long. Yes, we've gotten the output here. So the thing is that anytime, anywhere, whether with joins, and you have an aggregate within your line of code, it's always good to remember to use the group by function with the aggregated function. And we've gotten the yes. Good evening. Okay, the reason we are putting the e dot is because we specified that that column is e dot employee number. Like we specified, yes, we have employee number from salaries table and we have employee number from employees table, but the employee number we selected, it's not from the salary, but it's from the employee number. That's why we have to put the e. Yes. Yeah. So I hope I answered that question for someone who heard about running the codes. Okay. Yes, thank you. Yes, of course you can use the as function to give this average column. You see, we just said average as s dot salary, and the column name is avg into bracket s dot salary, the function itself. So to avoid that, you just add here as and give it a column name. Let's say avg. Let me type here avg for average underscore salary, to have just a common a column name other than the function involved. Yes. Okay, I don't think there's any necessity of renaming them since they already exist. For example, let me just do something. Okay, for example, okay, I don't know whether I remember to add the screen here. So we're having employee number. It already exists as employee number. Even down here, it's not existing as e dot. It's existing as just employee number. We're having first name, column name. We are renaming this because we are creating now a different column than whatever it is existing. In our data, we have salary, not average salary. So when we add average salary as a column, we are creating a new column containing the average salaries. Yeah. Okay, I hope I answered that. Okay. So I'll add a new SQL query tab here. Yeah, you can also use that. Yes. Yes. Yeah. So what we're going to be covering today is called case statements. And case statements, let me just share the screen for the notes. So we're going to be working with case statement. A case expression goes through conditions and returns a value when the first condition is met. I'll give an example with what we did yesterday. For example, yesterday we did the a function. Yeah, so we are selecting, and if the condition is met, the condition here that we are giving is met, we get the output. If it's not met, then what follows is provided, not. So that's what a case statement means. But now we'll have more conditions, not just two. We're going to have more conditions involved. So we're having an example: if, then, else. When you're having more condition, then so once a condition is true, it will stop reading and return the results. So once it finds that this is the correct answer that's being located, it will display the output, and then it stop reading the rest of the outputs. So if no conditions are true, it returns the value in the else clause. So we having if it's not true, then we have then. If then is not true, else is what will be our final output. This is how the case statement goes. We have case, you start the function case. So when the first condition, yeah, so I'll use the age category. So let's see a case when the age is less than 20, or let's say less than 15. Is it 15? Okay, let's say less than 18. Then the output should be young, yeah, or children. Then we have when you give the second condition, the second condition is when the age is between, let's say, 18 to 35. Then the result should be youth. The last category is when the age is greater than 35. Then you can go ahead and say elders, and so on. You can have as many when condition depending on what you're looking for. So you see we have when, you can have as many of them. Then else, what output should be given if all those conditions you tried to get were not true, or if there are other outputs that are not filled with the previous conditions. That's when we're going to be experiencing that. Yeah, so we're just going to use the same employees data set. So this is the syntax that we're going to be using. So I'll just go back to SQL. I've created, let me just minimize this. Yes. Okay. Yeah, this was the output. Go ahead. Yes. Yes. Okay. So yes, case the situation, the reason our output is mostly similar is because our work is generalized. That's why we were seeing that our data is up to future date, of which it hasn't reached yet. That means the data was generally stored for learning process, and everything is general, like the entries are equal. That's why you don't have nulls. But when you use the left or the right join, at some point you'll experience the null values. Yeah, that means a record exists in one table and doesn't exist in the other table. Yeah, so there are moments, yes, that you'll come to such a point. Okay, let me add, I was adding an SQL query tab, and this way we're going to be learning how to use the case statement. I'll start with the first function. So I'll just type the question and then we go through it together. Then I'll give you, let's say, another one, and then you'll try it and probably give your feedback later. So this is how the question looks like. We're going to type it. You can just add a comment and probably the slash one, just in case it becomes long enough. You have the slash and then the asterisk. So the question says you're supposed to obtain results using the employee dataset. So obtain results, result set, not results, result sets containing the employee's number. This is how a question comes, like we are dealing with a real life question. So obtain a result set containing the employee number. So we have the emp number, comma, first name, comma, last name, not comma, and last name, first name and a last name. Let me just read it again. Sorry. So you're supposed to obtain a result set containing employee number, first name and last name of all employees with a number higher than 109,990. So, and last, a name of all employees with a number higher than 109,990. You can hit enter because you use this last, so it will continue as a comment. So that's the first section. You're supposed to obtain first employee number, first name, last name of all employees. Oh yeah. Okay, let me do that. Sorry. We reduce that. Still not okay. Let me just minimize it a bit. I hope that's better. So we are obtaining result set containing the employee number. We have first name, last name, first name, last name, and last name of all employees with a number higher than 109,990. I've clicked enter so that the sentence is not too long, and since we used slash, the second sentence continues to be a comment. So that's the first section. The second section of the same question creates, supposed to be here, creates create a fourth column in the query indicating whether this employee is also a manager. Indicating whether this employee is also a manager. Add a comma. According to the data provided, let me just hit enter once more. Provided in the department manager table, in the department manager table, or a regular employee. So make sure after you type all the whole of the question, you go ahead and close the comment using the asterisk and then a slash, so that you close the comment section, and so that the next line will be a command line and not a comment area. So we are supposed to obtain results set containing one employee number, first name and last name. All these are coming from the employees table of all employees with a number higher than 109,990. One thing to note, anytime you're given a condition or a limit here, the same thing. For example, when you're having a specific amount you're supposed to extract. I'm talking about a case where we are given the number higher than 109,990. That means we have to limit. Yeah, we have to limit our output. So or use the greater than 109,990. The limit comes to the end once you've extracted the data. Then at the end, you'll indicate that you just need employees whose employee number is higher than 109,990. Another thing the second section says, create a fourth column. So we have three columns: employee number, first name and last name. We're going to create a fourth column in the same query, indicating whether a person is a manager or a regular employee. The table that will guide us to know whether a person is a manager is the department manager table, because that table stores data about managers alone. That means we're going to extract all records that from managers table, and if that an employee number exists in a department manager table, that means that person is a manager. Otherwise, if your employee number is not in the department manager, you're just a regular employee. So I hope you understood the question. Just in case, you can let me know. So we're going to go ahead and extract our output using the select statement, because we want to obtain the results. So we have select, and what we are selecting here is one employee number, first name and last name from the employee table. So I'll just type e.emp number, comma, e dot first name, comma, e dot last name. So these are the columns that we are supposed to extract, but we are supposed to add a fourth column, and we are the one creating it. And this is where we go ahead and use the case statement, so that we create now a fourth column with the information required, one indicating whether this person is a manager or not, depending on the data available. So this is how we go about it. You just add a comma after the last name, and then use the case statement. So we're going to say case, it's a function, a case when, remember, let me just show you how we said a case statement looks like. We said you have case, and then you start writing now down the conditions. So I have a case when the department employee number, remember we have said if your employee number is in the department manager table, it means you are a manager. I repeat, if your employee number, okay, let me just minimize this and show you the tables here where we are having the department manager table. I'll just expand it. You can see we have employee number and department number. Yeah, so if your employee number is in the department manager table, that means you are a manager, and that's what we're writing here. So when employee number, yes, okay, so I'm saying a case when employee number, in this case we are talking about employee number, not the employee number in the employees table, employee number in the department manager table. So we can abbreviate this employee number as department manager dot employee number, so that this employee number is not the employee number from employees table, but employee number from department manager. I'll abbreviate department manager table as DM, then add a dot. So I'm having employee number from department manager table. So a case when an employee number from the department manager table is not null, that means it exists, is not null, then that person is a manager. So we put quotes, manager. So I hope I did lose someone along the way. Yeah, let me just finish and then repeat it. So if a case when department employee number from the department manager is not null, then that person is a manager. Else that person is just a regular employee. So else, in quotes, you can just say employee and enclose that with quotes. So let me just also minimize this. So we are selecting employee number from the employees table, first name from the employees table, and last name from the employees table. Then we are adding a fourth column, and a fourth column is saying a case when employee number in the department manager table is not null. Is not null means if it exists. If an employee number exists in the department manager table, then that person is a manager. Else, if it doesn't exist, that person is just an employee. Yeah, so let me click enter. I don't know which whether this command will be too long, so I can just hit enter. It will be a continuation, there's no comma. Then once we are done with the when and else function, we end. Let me just go back to our notes, a case statement is ended using the end function. You can see end, like the end of the function. So we're going to add that. So I'll just add end mwisho, and then I give now this column a new name, as from where we have a case. This is one column, the fourth column, so you can go ahead and give it a name so that it doesn't exist as a column from here, case to end. So you want it as a new column, so we use the as function. So as, you can give it a column name is underscore manager. That's our column name, our fourth column name. Yeah, the next step is, now where are we getting this data from? Use the from function. From one, employees table. So we have employees table, abbreviate it as E, just as we did when selecting our columns. So employee table is abbreviated as E. Then we join. So someone would be asking, do we use the left join, do we use the right join, or something? The most recommended join for this extraction is left, so that we get all the employees that exist, so that we don't have, because if you use the right join, we're going to have only the managers, but you don't want that. You want to see people who are managers and employees, so we want all the employees, so we are going to use left join. Yeah, otherwise you can just use the natural join as we earlier said. So left join, yeah, we have left join, and we are joining department manager table. I guess it's written department manager. We abbreviated as, where we have dm dot employee number, that means we abbreviated as dm. That's the abbreviation for the department manager table. And then the matching columns, on, both of them contain employee number. It's always good to check on that. We have department manager has an employee number, and also the employees table has an employee number. Yeah, so on, on, we have e dot employee number is equals to dm dot employee number. Yeah, and then remember we had a condition before we run our output. We had a condition, and our condition was we have and last name of all employees with a number higher than 109,990. So you want all the employees whose their employee number is higher than 109,990. Yeah, 109,990. So we can go ahead and use the where clause. So we're using where, we are saying we want all the employees, but adding a condition where the employee number is greater than 109,990. E dot emp number is greater than 109,990. 109,990. Yeah, sorry. Is anybody having a question on what we currently have? Hello. Yes. For no, the alternative we said for where is having, and in most cases we are using having with the group by when you have a condition after the group by function. Yes, yes, yes. Mm-hmm. 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 That means you'll filter before you select, before the fourth column is created. Yeah, the where clause is used to filter out. We are filtering out, let's say, the employee number that are less than yes, 109,990. Okay, in most cases I've not seen a case where the where clause comes before the from function. Like you have to specify where the data is coming from, like select, let's say, employee number, first name, last name, from, and then where, not where then from. Yes. Uh-huh. Mm-hmm. Okay. No. Mm-hmm. Okay, you can try and play with the codes, but what I know is that, okay, you can't do a case, you can't start the case statement where we're having a case when after from. You can't have the from and then begin creating another column. You select all the columns that you want. If you're creating others, you create them. Then after that, you say where are you getting this data from. So you have to create the columns first. Yes. Mm-hmm. 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 Yeah, of course you can. Oh yeah, you can choose different wordings, but of course if you're told give them, I earlier said that when you're extracting data, maybe you need a certain data that's from different table that's reading into joining different tables. So if you're going to rename or create a new column, you name it in a way you're going to understand the output. Yes. Okay, so let's execute our code. And you can see we got it right. We're not having an error, and this is the output. So we're having employee number was our first column, we have our second column, first name, we have last name, our third column. And on that note, you can also confirm that our employee number is greater than 109,990. we're having 109,991 is the first one here, and then we have the column is manager, where I give the column name as well. You can give a column name differently depending on the data set that you're working and what that column will hold, just to make it your work easier to understand all the column really entails. So we have our column is manager, we are having employees, you can see here we have a manager. So yeah, that's what we're looking for. We wanted to see people who are a manager and those who are not, and we can see them according to their employee number, their first name, and their last name. Any question? Maybe someone encountered an error, you can just let me know the error. If not, I hope we are together at that. So I'll give you a question. You're supposed to work on this and give you feedback. So here's the question. Let's write it down together. So yes, because it's a long sentence, we said we're using the slash and then asterisk. And our question goes, extract the employee number. Extract, missing something. Extract, yeah, employee number. We have first name and last name. First name and last name. Yeah, first name and last name of all of, not all, of the first 100 employees. So of the first 100 employees. So we're extracting employee number, first name and last name of the first 100 employees. I'll add enter. The next section is of the question says, add a fourth column. So add a fourth column. Add a fourth column called, this is how you'll call the fourth column. Let me just put it in quotes. You're going to call the fourth column current employee. Yeah, that's the fourth column name, and it will be saying, so we are adding a fourth column called employee, saying whether is still employed, whether is still employed that means if the person is still working in the company, or not an employee anymore. So we're extracting employee number, first name, last name of the first 100 employees. We are adding a fourth column called current employee, and it will be saying whether, you're saying whether, I wrote where, not where, whether, saying whether is still employed, or so if when you talk about saying whether is still employed, it means that that person is still working the company or not an employee anymore. Yeah, so they are not working the company anymore. Is the question clear? Does anybody need some clarification on the question? Yes. Okay, basically what is going to limit this employee is the employee number. not the salary, not their first name. Yeah, the only unique here in our column, the unique column is the employee number. You're going to limit this to what do you say, according to employee number. Okay, let me show you something else. I don't know whether it will be visible. I don't know whether you realize. Okay, normally when you're extracting a record and you want to limit, you use the function limit at the end of the query. Yeah, at the end of the query, once you've done it with everything, you can go ahead and say limit 100 and then close the query. But on the other hand, I don't know whether this will also give the effects of the same. You see, where we're having the names of our SQL scripts. So we have in my case, I'm having create table, employee, we have create database, we have all this file I've been working for. Then down here we're having the tabs. For example, we're having the one for opening an SQL script. So we have the execute buttons. But the same line with those ones, we have limit to, and then cut drop down. We have limit to 10 rows, limit to. Okay, let's see how it works. I'm going to execute a line of command. I hope you can hear me. Let me just check on my internet. Just a minute. Okay. So sorry for that. As I was saying, I wanted to limit a specific entry and see whether I'll get the output. For example, I'll just run the previous line of codes. I'll execute that. Then I'll limit this. Let's say limit to 10. Okay, let me run that after limiting. Let me see. Yes, actually it's limiting. You can see now we have just few entries, but you limit before you run the command. But the one known command, there is a function called limit, used to limit. You just write it at the end of the command line. Just limit to say less 100, limit to 200, and then you'll still get the output. Yes, so I hope you're good. We're going for a short break, and then we come back and finalize on our SQL work. Yeah, we're going to manage. So yes. Okay, let me just do something here.